All right, so today we're going to talk about how to solve rational equations. Just a quick reminder, the word rational, remember rational numbers that we talked about earlier in this class? The word rational means it could be, rational number could be written as a fraction. So rational equations are equations that have fractions in them. So if you want to kind of relate those two words together, like rational and fractions. Specifically, these equations have variables in the denominator. So here's an example. I've got 6 over k squared equals 2 over k minus 1 over k squared. When we go to solve rational equations, our strategy is going to be this. Make a little note of this up to the side, is we want to eliminate all the fractions. And the way we're going to do that is we're going to eliminate the fractions by multiplying by the LCD. Remember, LCD stands for the least common denominator. Okay, so let's try this problem right here. So think of k squared as being, it's got two factors. It's got a factor of k and k. This just has a single factor k, and this one has two. So when you go to find the LCD, we have to include all the different factors. In this case, there's only one factor, it's just k. And we have to look at the one that has the most, and that's how many we include. So if you look, the first one has 2k, second one has 1, the third one has 2. So my LCD is I have to include k, and I have to include 2 of them because the most any single term has is 2. Okay, now I'm going to multiply both sides by that k squared. And the reason why we did that is because, watch what happens. When I multiply by k squared, it's going to cancel out or reduce with my denominators and leave me with an equation that doesn't have fractions anymore. So this one, when I times by k squared, the k squared just cancel out. On the next one, I have to distribute this one through here. So I times first by there. Now this is where it gets a little bit tricky. I have 1k in the bottom. It's going to eliminate with one of the k's that I'm timesing by. Oh, there's a 2. So it's 2 times. And because I eliminated 1k, there's 1k left over. Times, distribute it through here also. That one has a k squared and a k squared. They're just going to cancel out. So what happens when we do that is we end up with an equation that no longer has fractions, and then we just use our equation solving skills that we already know. So in this case, all I have to do is just get k by itself. Let's add the 1 over. 7 equals 2k. Divide by 2. There's our answer. There's one last thing we have to worry about. There are times when you get an answer that won't work. And the reason why it won't work is if you look at the denominator, you cannot have 0 on the bottom of the fraction. That's something else we talked about earlier in the year also, right? No 0. You can't divide by 0. No 0 in the denominator. So you've got to make sure that whatever answer you get right here, that if I plug it back in, it won't give me a 0 in the denominator, which we're good. If I plug 7 halves and square, I don't know what it is, but it's not 0. If I plug 7 halves there or 7 halves there, I do not end up with 0 in the denominator. So make sure you take just a second and check that. Let's get past this, and let's do this one right here. So on that last problem, there was just a single term in the denominator. If you have more than one term, then you have to factor everything before you find the LCD. So I'm going to factor here. Look at the first one. It's v squared plus 3v. We have a common factor of v. So I'm going to take out a v. That leaves me with v plus 3. This next one's the same, v squared plus 3v. So again, take out a v. And this one just has a single term. It's just v. Okay, when you go to find the LCD, you have to include all the different factors. Remember, v is considered a factor and v plus 3 is considered a factor. Remember, factor are things that are multiplied together, and the v is multiplied by the v plus 3. Okay, so I need to include them both, so I'm going to include the v and the v plus 3. That's what I have to multiply. So I'm going to rewrite my problem. I have 5 over v times v plus 3 equals 1 over v times v plus 3. Plus 1 over v. Okay, multiply both sides by that v times v plus 3. And again, what's going to happen is all of our fractions should cancel out. Whoops. An extra set of parentheses there. Okay, so over here, that just cancels out completely. The v and the v cancel, the v plus 3 and the v plus 3 cancel. I have 5. Okay, over here, distribute through. Same thing. The v and the v plus 3 cancel with the v and the v plus 3. I just have 1. Times by the next one. The v and the v cancel on that one, which leave me with 1 times v plus 3. And the 1 comes from here, and then I have that v plus 3 left over there when I multiply. Okay, again, use our good problem-solving skills. 5 equals 1 plus, distribute that 1 through. So now I have 5 equals v plus 4 minus the 4 over, so v equals 1. Okay, go back and check. If I plug 1 in, will I get a 0 in the denominator? So if I put 1 in here, I do not get a 0. If I put 1 here and here, I don't get a 0 either time. So we're good. That would be our solution. Okay, v is equal to 1. So again, first thing we're going to do is, if necessary, factor the denominators. Second thing is find the LCD and multiply it by it. That should get rid of all our fractions. And the third thing is just solve the resulting equation. The last thing is make sure your answer does not give you a 0 in the denominator of the fraction. All right, let's try this one, and I have one other one, just a different type that I want you to see. All right, so we're going to start out, make sure everything's factored. X minus 5 does not factor. So I'm going to put it in parentheses. That means it by itself is a factor. Same thing with x plus 4, it does not factor. So it by itself is a factor. X squared minus x minus 20 does factor, right? We do 2 sets of parentheses. Take the factors of, what do I times get x squared, so x and x. Then we take the factors of negative 20. Negative 1 and 20. I'm looking for the ones that add up to be a negative 1. So I think it's that negative, well, negative 4 and 5 add up to be positive 1. I'm just going to flip the signs. So plus 4 minus 5. Okay, decide what the LCD is. So the LCD, we have to include all the different factors. Well, I've got x plus 5, or x minus 5, excuse me. I've also got an x plus 4. Okay, and that's it. That's all we have is x plus 5s and x minus 4s. So we're going to come over here. I have 4 over x minus 5 equals 1 over x plus 4 plus 4 over x minus 5 times x plus 4. Okay, so we're going to multiply this side by x minus 5, x plus 4. And what happens is those two just cancel. So I'm left with a 4 times x plus 4. Okay, do the same thing over here. Okay, so I'm going to distribute that through. The x plus 4's cancel. I have 1 times x minus 5. Okay, times it through here. Those two would both cancel with those two, so you don't have anything left over at all. Okay, go ahead and distribute. I end up with 4x plus 16 equals, distribute the 1 through, x minus 5 plus 4. So I've got 4x plus 16 equal x minus 5 plus 4 is minus 1. I'm going to minus x from both sides. Just using our problem-solving skills here. All right, 3x plus 16 equals negative 1. Minus 16 over. 3x equals a negative 17. Divide by 3. And you'll get this a lot on these problems. A lot of times you'll end up with fractions. Hey, just double check. If I plug in negative 17 over 3, I don't even know what that is for sure, but when I minus 5 from that, it's not going to be 0. And add 4 to it, it's not going to be 0. So we're good. That would be our solution. Hey, let me show you this one other type before we end here. Not that, right here. What I want to point out is this one, not all of the terms have fractions. Like the first two do, the third doesn't. So we're going to go through. Let's start out again by finding the LCD. Make sure everything's factored. This one's nice because k plus 6 doesn't factor, and that really is your only factor. So when I go to find the LCD, there's only one factor, and it's k plus 6. That's what I'm going to have to multiply everything by. So let's multiply the left side by k plus 6. So we're going to multiply the right side by k plus 6. Okay, over here, all that happens is those two just cancel. 4 is equal to, over here on this side, as I distribute this through, that one, the k plus 6 and the k plus 6 cancel, leave me with a 1 minus. You have to multiply it by the 1 also. And when that 1 does not have a fraction, so nothing is going to cancel. It just stays k plus 6. Okay, hard stuff's done. Just solve it like we would a normal equation. 4 equals 1. That would be minus 1k minus 6. We can combine the 1 and the minus 6 together. That would be, so negative 1k minus 5. Just combine those two. Add the 5 over. Divide by negative 1. So k is equal to negative 9. Okay, double check. When I plug negative 9 plus 6 does not equal 0. So we're safe there. Okay, so remember, our whole goal is when you have a rational equation is to get rid of the fractions. The way we get rid of the fractions is you look at all the denominators, you make sure they're factored, find the LCD, the least common denominator, and you multiply both sides by that, and that will eliminate all your fractions. Once you get to there, you solve the equation. Just make sure when you get your final answer that it's not going to give you a 0 in the denominator of the fraction. And that should be it. Thanks, guys.